Hello friends, welcome to my channel Banthiya's Training and Consultancy. My name is Banthiya and we have already seen in the last lecture about the basic concept of Gay-Lussac's law. Today we are going to see a couple of numericals based on Gay-Lussac's law. And if you have not seen that video, please find the link above. So let's start. The first question is, nitrogen reacts with hydrogen to give ammonia. Calculate the volume of ammonia gas formed when nitrogen reacts with 6 liters of hydrogen, all volumes measured at s.t.p. Now let's try to write the balanced chemical equation. We know that nitrogen is N2, hydrogen is H2, and which will give ammonia, that is NH3. Now if you want to balance it, this will be 3 and this will be 2, and now it's a balanced equation. And according to the Gay-Lussac's law that we have already seen in the last video, the ratio would be 1:3:2. The amount of hydrogen gas given here is 6 liters. So that is equivalent to 3 parts. So 1 part would be 2 liters, and therefore ammonia that will be produced will be 2 parts, which will be equals to 2 into 2 liters, that is 4 liters. Now let's see the next. Now let's see, here it is given 2500 cc of oxygen was burnt with 600 cc of ethane. Calculate the volume of unused oxygen and the volume of carbon dioxide that is formed. Let's try to write a balanced equation here first. C2H6 plus O2 gives CO2 plus H2O. So to balance it, we will get 2C2H6 plus 7O2 will give 4CO2 plus 6H2O. So this is a balanced equation. So now let's try and apply the Gay-Lussac's law, which states that the combining volumes are constant. That is 2 is to 7 is to 4 is to 6. Assuming that H2O is not a liquid but it's a gas here. So now we have been given quantity of oxygen to be 2500 cc, ethane to be 600 cc, carbon dioxide is to be found out, and unused oxygen is to be found out. So unused oxygen means the volume of oxygen is in excess as per the question. So let's directly try and attempt this question by using ethane, that is 2 parts of ethane will be 600 cc. So 1 part will be equals to 300 cc, and oxygen is 7 parts as per the whole number ratio. So this will be 2100 cc. 2100 cc of oxygen will be used, and again 4 parts of carbon dioxide is produced. So 4 parts of carbon dioxide would be 1200 cc of carbon dioxide, and 2500 cc of oxygen is given to us. So the remaining oxygen would be 400 cc, that is residual oxygen will be 400 cc, and the produced CO2 will be 1200 cc, and that's the entire solution for this question. Now let's see the next question. 100 ml each of oxygen and hydrogen and 10 ml of carbon monoxide are exploded in an enclosure. What will be the volume and composition of the mixture of the gases when they are cooled to room temperature? Oxygen and hydrogen are given 20 ml each, and carbon monoxide is exploded, which is again 10 ml given. So basically your explosion will be of hydrogen which will react with oxygen to form H2O, and here it is cooled to room temperature, hence this will be liquid, and the other reaction would be carbon monoxide plus oxygen will give carbon dioxide. Now let's try and balance this. This will be two molecules of carbon monoxide will react with one molecule of oxygen to give 2 molecules of carbon dioxide, and 2 molecules of H2 will react with 1 molecule of oxygen to give 2 volumes, that is 2 molecules of H2O will be formed. So now applying Gay-Lussac's law to this equations, both the equations, these are the 2 equations that we see. So according to Gay-Lussac's law, it will be 2:1:2 nothing because it's a liquid, and in this case 2:1:2. We already know that carbon dioxide is gas at room temperature. So we have been given hydrogen to be 20 ml and oxygen as well to be 20 ml, but we will consider that 20 ml later on. So 20 ml, that is one part would be 10 ml, and hence 10 ml of oxygen will be consumed in this reaction, and carbon monoxide is given 10 ml which will react with one part, that is 5 ml of oxygen to give 2 parts, that is 10 ml of carbon dioxide. Now if you have observed, we have consumed 10 plus 5, that is total 15 ml of oxygen from 20 ml. So we are left with 5 ml of oxygen here. The composition of the resultant mixture and the volume would be, we will get the remaining oxygen, that is 5 ml, then we will get carbon dioxide as 10 ml, and this will be all as per Gay-Lussac's law. The product water cannot be considered as the composition in the final composition as it is liquid at room temperature. So this is the final answer. Now let's see the next numerical. 224 cc of ammonia undergoes catalytic oxidation in presence of platinum to give nitric oxide and water vapor. Basically the reaction should be like this: NH3 plus O2 catalytic oxidation to give nitric oxide plus water. So this should be the reaction. So the balanced equation would be now once we have got the balanced equation, let's apply Gay-Lussac's law to this equation, that is a chemical equation. So we get 4:5:4:6. But here one more thing that we have missed is all volumes are measured at room temperature. At room temperature this will be liquid, and hence H2O cannot be considered. Calculate the volume of oxygen required for the reaction. That is the question, and we are undertaking 224 cc of ammonia. So basically one part would be equals to 224 by 4, which comes out to be 56 per part, and the total volume of oxygen that is required for this reaction is 5, that is 5 into 56, which will be 280 cc of oxygen, and this will be your final answer. I hope guys that you are understanding that how these questions are to be dealt with. In case you have any doubts, please feel free to ask in the comment section below. Thank you for watching this video. Please subscribe, like and share this video, and don't forget to press the bell icon. Thank you.